Hello everyone, welcome to session 3 of module 3, Static Analysis by Tools. In this session we will understand what is static analysis and what are the tools used to do static analysis. So static analysis is the examination of requirements, design document or any software code without executing the artifact in the test. So main objective of static analysis is to find defects before coding starts and software code is actually run. So the objective of static analysis is to find defects in any sort of software artifacts like requirements or a design documents or the software code itself without executing the code. So as we discussed in static testing techniques, it's static analysis is kind of similar thing, but it's more of done for the document or for the actual code when developer starts to start the coding without running the code. Then goal of static analysis is to find defects rather than failure. So the main goal of static analysis is to find any defects in the document or in the code without being executing it. So if the code doesn't follow certain standards, the tool can be used to check whether it follows the specified standard or not. So you can use certain tools to do static analysis of the code before actually doing a build and executing the code. So the main goal of static analysis is to find such kind of defects. Once static analysis is done, build is done, then in actual testing, in dynamic testing, you find failure rather than defect. So in dynamic testing, you mostly find the failures, that software is not working as per expected. Then what are the different tools for static analysis? So static analysis tools are mostly used by developers during unit integration testing and by designers during modeling. So most of the static analysis tools are used by the developers during their unit or integration testing, or they are used by the designers, software designers during modeling. So the tools provide details about coding standards like nesting depth, cyclomatic complexity, checking against coding standards, and graphic depictions of the control flow. So the tools for static analysis that are being used by developers, they provide a lot of information about the code that they write. These tools provide information about the cyclomatic complexity of the code, whether the code is following the standard defined in that organization or whether it is following the normal general standard coding standard, whether it provides all information about nesting depth. It provides information in graphical format about the control flow of the code. So the static analysis tool is very useful for the developers. So you can say the compiler or development IDE is also a type of static analysis tool. If you would have heard about Eclipse IDE, that is mostly used by Java enterprise developers, that is also a static analysis tool because IDE gives you a clear information about the coding standards, or it checks against the standard. It checks the basic format of the code that you write. So it provides a lot of information about the code. It provides graphical depictions or the control flow of the code as well. Then static analysis tool analyze software code and the output generated by the code. So these tools analyze your code as well as they analyze any output that is being generated by the code, so like XML or HTML as well. So static analysis helps to find defects which are difficult to find during dynamic testing. So static analysis is very helpful as in static testing. So it helps to find any issues which are very difficult to find during dynamic testing. So some of the typical defects found by static analysis tools are so like unused variables. So if you talk about IDE, any development IDE or Eclipse IDE, if you have defined a variable and it's not used anywhere in the program, it will give you a warning about that unused variable. So these are some of the typical defects that can be found by the tool itself without executing the code. So if there is any unused variable, it will be easily found by the tool. If there is some unreachable code which is not used at all, that can be found by the tool as well. If there are any security vulnerabilities, you did not follow the proper coding standard or violations, if there are any syntax issues, you have opening braces, you forgot to apply a closing brace, you forgot to follow the proper naming conventions for the variables. So all such kind of issues are easily detected by the static analysis tools. Then typical benefits of static analysis. First benefit is defects are detected prior to test execution. So that's the first benefit. So you do not have to wait for defects before doing a test execution. Defects are found prior to the execution begins. Then it is very effective in finding defects that are difficult to find by dynamic testing. Static analysis is very helpful at some situations where dynamic testing cannot find defects. Then static analysis tools give warning about any incorrect code format or structure. So check in Eclipse IDE, it will give you warnings about or errors about any incorrect code format or any structure. If you have missed it, gives all those sort of warnings. Then using static analysis improves maintainability of the code. So since if you're using static analysis tool, you follow the standard, and if you follow the standard, the code is more maintainable in future. Now, what are the features of static analysis tool? Let's discuss the main features provided by static analysis tools. So these are the three main features that are provided by static analysis tool. The first one is coding standards. It provides coding standard, certain coding standard that you can follow. It provides information on code metrics, and it provides information on code structure as well. So let's discuss these features one by one. So coding standard. Static analysis tool checks adherence to coding standard. So programming rules like warning if declared variable is not used in the code. Then naming convention also checks naming conventions, like class name should always start with capital C. So these are kind of checks that static analysis tool does. If there is any issues against these, then it will give you a warning about the standards. Then it is recommended that you adopt to existing standards. So since there are a lot of existing coding standard which are already there in the tool that you use for static analysis, so it is always recommended to adopt the existing standard that is provided by the static analysis tool. Why it is recommended? Because it saves a lot of time. You do not have to define your own coding standard, so you can just follow the existing standard, and then because coding standard is well known, there may be many checking tools available which will support that standard. So if you'll follow already existing coding standard, there will be a lot of tools available which you can use to analyze the standard in future. If you want to use some other tools to analyze your code, then you can use other tools if you are following the existing coding standard. Then the other feature is CodeMetrics. So CodeMetrics is about calculating structural attributes of code like depth of nesting, cyclomatic complexity, numbers of lines of code. So this is another feature that is provided by static analysis tool. So CodeMetrics is nothing but calculating the structural attributes, like what is the level of depthing of the code, what is the complexity of the code, how many lines of code is there in the total software. So all these kind of metrics are also provided by the static analysis tool. And these metrics are helpful to see if the design of code is becoming bigger and complex. It is very important to see these metrics because these metrics help you to estimate what is the complexity of the software, how big is the software. Then CodeMetrics also help to decide about design alternatives when redesigning the existing code. So if you have found that this module of the software is of high level of complexity and requires a lot of testing, then you can, if you have that information, then you can think of different alternatives to implement that same module in a simpler way, which is less complex and requires less effort to test, and also makes software more reliable. So if the more complex the code is, the more testing it requires, and more complex it becomes to, more difficult it becomes to maintain that software or the piece of code. So if you have the CodeMetrics about different modules or the software as a whole, then you can think of different alternatives to design your code in a better way to make it more simple and maintainable. Then let's discuss cyclomatic complexity. So this is another complexity measure for the code. So cyclomatic complexity metric is based on number of decisions in the program. So it is based on the number of decisions that are there in the program. It is very important for testing because it provides information about the complex code which requires more testing. So it is important because it provides information about more complex code. So if cyclomatic complexity is more, then you require more testing around it. If it is less, then require less testing, because it's complexity that's decide the complexity of the code. If cyclomatic complexity is more, that means your software code is more complex and it will require more testing. So how do you calculate cyclomatic complexity? We'll see some formulas to calculate cyclomatic complexity. The simplest way is to count number of binary decisions statements like if, while, for, etc., and then add 1 to it. That's the simplest way to find out cyclomatic complexity for any module that you are testing. The other formal approach is to use the formula given below, that is total number of edges minus total number of nodes plus 2. So edges is, if you in the next page we'll see the example and see how we can calculate complexity for a little piece of code that I have taken. So here's the simple piece of code and a flowchart for it. So if A is equal to 1 to 3, then if B greater than C, then A is equal to B, else A is equal to C, and print A. And for this this same code, I have created a flowchart. So with the first way, if you want to calculate cyclomatic complexity, the simplest way is to count the number of decision statements. So in this code at the top, there are two if statements. The first, if A is equal to 1 to 3, then if B greater than C. So these are the only two decision statements in this code. So with the first formula, number of binary decisions plus 1, the cyclomatic complexity comes to 2 plus 1, which is 3. With more standard way to calculate, so you need to find total number of edges minus total number of nodes plus 2. So you need to follow this flow chart. So if you see this flow chart, how many edges are there? So these are the edges. So this is one edge, this arrow that connects this if box to the end if. So one edge, second edge is here, third edge, fourth, fifth, sixth, seventh, and eighth edge. So total number of edges is 8 minus total number of nodes. These are the nodes. The boxes, all the boxes are the nodes. So count the nodes: 1, 2, 3, 4, 5, 6, 7. So edges were 8, nodes were 7. So 8 minus 7 plus 2. So 8 minus 7 is 1. 1 plus 2 is 3. So cyclomatic complexity is 3 for this part of code. So similarly, if you want to calculate cyclomatic complexity for other code or flowchart, you can just use these formula to calculate the complexity. More the complexity of the code, more testing is required to test that piece of software, piece of code. Then the third feature that is provided by static analysis tool is the code structure. It provides information about the code structure as well. So several aspects of the code structure to consider are control flow structure, data flow structure, and data structure. So these are different aspects that you need to consider: control flow, data flow, and data structure. So all these aspects are provided by your static analysis tool. So what is control flow structure? Let's understand what is control flow structure. Control flow structure addresses the sequence in which instructions are executed. So it just addresses the sequence in which instructions get executed. Then control flow structure reflects the iterations and looks in a program design. So it reflects the iterations in the code. Then used to identify dead code. The control flow structure is used to identify any dead code, any code that is not being exercised. Then code metrics like cyclomatic complexity, number of nested levels relate to control flow. So any metrics like cyclomatic complexity or number of nested levels relate to control flow of the code. Then data flow structure. So what is data flow? A data flow structure follows the trail of a data item as it is accessed and modified by the code. So like in control flow, you were just following the code flow, how the code is flowing while you are doing some test on the code, how the flow is happening. And it was main purpose of it was to find any dead code, any code that is not being exercised by the test you are doing. Then data flow structure it follows the trail of a data item as it is accessed and modified by the code. So you check a data item and then you verify how that data item is being modified when it is accessed by the code. So suppose a value in database for a variable is 100, then you keep an eye on that variable in the database, and while the code is accessing that variable and modifying that variable, you keep an eye on that data and see how it's getting accessed and modified by the piece of code that you are testing. So data flow structure focuses on the data, not on the code. Then data flow structure helps us to figure out how data is transformed by the program. So you keep an eye on the data and see how it is transformed by the program. Some common defects found by data flow structure are like referencing a variable with undefined value or variable which is never used in the program. So these are the kind of defects that you can find by data flow structure. There might be variable which are never used in the program, or you are referencing a variable which is not even defined in the program and you are referring to that variable. So these kind of defects can be found by the data flow structure. Then data structure. So data structure refers to the data independent of program. Data structure is kind of independent thing, and you refer to the data independent of the program. That's completely separate thing. It refers to algorithms for creating, modifying, or deleting data. The data structure refers to the algorithms which are used to create, modify, or delete the data. Knowledge of these algorithms provide a lot of information about the difficulty in writing programs to handle the data. So it is very important to have knowledge of these algorithms, because if you'll have knowledge of the data structures, how data is being organized, created, and modified, what the algorithm is behind the data, then it becomes easier to write programs to handle that data. You will be able to write simpler and easier program to handle the data structure properly. Then sometimes the program is complex because of the complex algorithm for data structure and not because of the complex control flow or data flow. So data structure, knowledge of data structure is important because sometimes the data structure itself is so complex that the complexity of the program is because of the data structure and not because of the control flow or data flow. So in such kind of situations, you can think, if you have good knowledge of data structure, you can think of implementing you can think of using different data structure to make your program less complex and make it more simple. So to conclude, in this session, we learned about what is static analysis, what are the typical benefits of static analysis, then what tools for static analysis. You can use different tools for static analysis, and then we learn about the basic features that are provided by static analysis tools. Features like coding standards, they provide information on coding metrics, they provide information on code structure, etc. Thank you.